In the last module, we were introduced to the concept of perfect competition. And in this module, we're going to explore in more depth how we graph perfect competition and learn more about economic profits and losses and when a firm may decide to shut down and not even operate and choose to do something different with its resources. Okay, so in this module, the first thing we're going to do is to evaluate a perfectly competitive firm situation using a graph. We will continue our discussion from the last module to determine a perfect competitor's profit or loss and explain how a firm decides whether to produce or to shut down in the short run. Now, in the previous module, there was a perfectly competitive firm, remember, that was selling melons at a price of $8 each, and the marginal cost and average total cost data were computed. And we talked about total profit. And we said that total profit can be expressed in terms of profit per unit, where profit is equal to total revenue minus total cost, which is equal to the total revenue divided by the quantity minus the total cost divided by the quantity multiplied by the quantity. Or equivalently, because price is equal to the total revenue divided by the quantity, and average total cost is equal to total cost divided by the quantity, then we could say profit is equal to price minus average total cost multiplied by the quantity. And that's how we could calculate profit, total profit, or profit per unit. Now, here's a tip for the AP exam. Memorize the formula for profit, because you're not going to be given a formula sheet for the AP exam. So any formulas we learn in this course, you have to memorize because you're not given formulas on the exam. So now let's go back to Melanie's melons. Okay? And we see here that the firm is producing a quantity of 5 melons because that is the output where price is equal to marginal revenue, which is equal to marginal cost. And we can see that in the graph that we're going to look at. We also showed how to compute per unit profit. And I'm showing that again here. Profit per unit is profit divided by quantity, which is equal to total revenue divided by quantity minus total cost divided by quantity. When we rearrange that equation, we compute total profit. We get profit equal to total revenue divided by the quantity minus total cost divided by the quantity multiplied by the quantity. And we recognize that total revenue divided by quantity is equal to average revenue. We also know that average revenue is equal to the price. And we notice that total cost divided by the quantity is equal to average total cost. And so we rewrite total profit as profit is equal to price minus average total cost multiplied by the quantity. And so if we look at the graph from the previous module, it's possible to see profit in the graph as a rectangle. The area of a rectangle, remember, is length times width. And the length of the rectangle in the graph here is a quantity of 5 melons. And the width is equal to $8 minus $6, which equals a profit of $2 per unit. So the area of the profit rectangle is $2 per melon multiplied by 5 melons, which is equal to $10. Now, this situation shows a firm that is earning some positive economic profit. But what would happen if the price fell? Well, as we learned in the previous module, positive or negative economic profit depends upon whether the price is greater than or less than average total cost. Again, here we see profitability determined in this graph. So we take the width, which is 18 minus 1440, and multiply that by a quantity of 5 tomatoes, and that gives us our economic profit. So, again, we can say profit is equal to price minus average total cost multiplied by the quantity. So we know if the price is greater than the average total cost, we said the economic economic profit must be greater than zero and positive. If profit is less than average total cost, economic profit must be less than zero and negative. And if price is equal to average total cost, then economic profit must be equal to zero or a normal profit. So this graph shows how negative economic profit, or what we call economic losses, can be drawn. The firm still produces the quantity where price is equal to marginal revenue, which is equal to marginal cost. The only thing that is different in this graph is that the price has fallen below the average total cost curve. It is no longer above the average total cost curve. If the price is above the average total cost curve, then we're earning economic profit. If the price is below the average total cost curve, then we're incurring economic losses. So instead of drawing a profit rectangle, we can describe this as a loss rectangle. And how do we determine what that loss is? Well, the width is going to be average total cost minus the price multiplied by the quantity that we sell. And we shade that area, and that's the area of economic loss. Just as in the previous one, price minus average total cost, when average total cost was below the price, that we multiplied by the quantity, and that showed economic profit. And we shaded that area as well. So you need to be able to draw a graph in a perfectly competitive market showing economic profits or economic losses. And remember, when you draw your graph, always start out by drawing your marginal revenue curve, which will always be a horizontal, perfectly elastic demand curve equal to the price, equal to the average revenue. Then draw your Nike swoosh or upward sloping marginal cost curve and make sure that the two curves intersect at the profit maximizing quantity. Once you've done that, then you draw an average total cost curve, and it's always going to be U-shaped. If you're showing economic profit, then you want to draw an average total cost curve where it intersects the quantity produced below the price. If you're trying to show an economic loss, then you want that average total cost curve to be drawn above the price and then shade the area of economic loss. So you need to know how to draw both. Again, here's another graph just showing the same thing. You take the average total cost of $14.67, subtract it from the price of $10, multiply it by the loss minimizing quantity, which in this case is 3, and you see the average total cost curve here drawn above the price rather than below the price. So that tells us we're showing economic losses rather than economic profits. And you can see the minimum average total cost would be at point C. But the profit or the loss minimizing quantity would be point A. Now, remember, as I've told you, on the AP exam, questions may give you a scenario about profit, cost, or revenue at a specific output. Drawing the firm's graph may help you visualize your answer more easily, so make sure you do that. So, what is the firm's break-even price? The break-even price of a price-taking firm is the market price at which it earns zero economic profits, or what we call a normal profit. And whenever market price exceeds minimum average total cost, the producer is profitable and earning positive economic profits. Whenever the market price is equal to minimum average total cost, then the producer is breaking even and earning a normal profit. And whenever market price is less than minimum average total cost, then the producer is incurring economic losses and is unprofitable. So this graph shows the situation where economic profit is equal to zero. We've described this before as a normal profit. This is a break-even outcome. And this break-even outcome occurs when the profit maximizing output or quantity is at the point where the price is equal to the marginal revenue, it's equal to the marginal cost, but it's also equal to average total cost. Average total cost is not above or below the price. This can only happen at the minimum of the average total cost curve. So when price equals average total cost, the rectangle of profit or loss does not exist. This price is called the break-even price, and the minimum of the average total cost curve is called the break-even point. So if we go back to this graph right here, we can see that the loss minimizing output is point A, a quantity of 3. And then we go up to the average total cost curve to point Y and draw a line over to determine the rectangle and calculate the area of economic loss. But what would the break-even point be? The break-even point would be a quantity of 4 tomatoes, and that would be point C, because that is the minimum of the average total cost curve. And so if we were producing 4 tomatoes, we would actually be breaking even rather than incurring an economic loss. So now we need to talk about a firm's short-run production decision. How much does it produce in the short run, that period of time when at least one variable is fixed in quantity? If the price of the product is so low and losses are being incurred, why would a firm even continue to produce where price equals marginal revenue and equals marginal cost? You might think, if a firm is earning economic losses, shouldn't it choose to close and shut down immediately? Well, not necessarily. Not necessarily. Not in the short run. In the long run, yes. But in the short run, when it can't get rid of one of its fixed cost variables, that decision is different. So let's try to explain the shutdown decision using both intuition and a simple numerical example. First, let's use our intuition. Consider what happens when the firm produces some quantity where the price is equal to the marginal revenue, which is equal to the marginal cost. Two things happen when you produce this. One good thing and one bad thing. The good thing that happens is you're earning total revenue. Because you're selling something, money is coming in. The bad thing is that cost is being incurred. It costs you something to produce it. Specifically, total variable cost is incurred. The more you produce, the higher your variable cost. The less you produce, the lower your variable cost. But you are always going to have fixed cost. So the firm should really weigh the revenue dollars coming in against the cost dollars going out. If total revenue is greater than or equal to total variable cost, not total cost, but total variable cost, because that's something you can control with your quantity of output, then the firm should produce where price is equal to the marginal revenue equals to marginal cost, even if it's losing money. On a per unit basis, the firm should produce if price is greater than or equal to average variable cost. But what if total revenue is greater than total variable cost and still economic losses are occurring? Should we shut down and produce a quantity of 0? What would happen if we did that? Well, profit would equal total revenue minus total variable cost minus our total fixed cost that we have to pay for anyway. So if the quantity we're producing is equal to 0, then profit is going to be equal to 0 minus 0 minus our total fixed cost, because we still have our total fixed cost. Remember, even if we're producing nothing, we still have to pay our fixed cost. That's why it's fixed. So that means we would have a negative total fixed cost. So our losses are equal to total fixed costs in this situation. The costs that we incur no matter the level of output. But because we have a case where total revenue is greater than total variable cost, the term in parentheses is some positive number. So profit equals a positive number minus total fixed cost. And if we are adding a positive number to the lost total fixed cost, our losses are somewhat smaller. In other words, by producing, we are minimizing our losses because we are earning enough to cover all of the total variable cost and part of the total fixed cost that we can't get rid of. And if we can at least cover all of our total variable cost, which we can control, and some of the total fixed cost that we have to pay anyway, then we should produce, because we're at least paying some of our total fixed cost. Therefore, the shutdown decision to produce a quantity of 0 is only made if total revenue is less than the total variable cost, or if the price is less than the average variable cost. If this is the case, we should then produce nothing in the short run and incur losses equal to the total fixed cost. Now, let's look at a numerical example. That was using our intuition. Let's look at an actual real example of this. Suppose a coffee shop sells cups of coffee at $2 each in a perfectly competitive market. The owner of the coffee shop has a total fixed cost of $10. He has to pay it anyway, no matter what he produces. The owner finds that the price is equal to the marginal revenue and equal to the marginal cost at $2, and at a quantity of 8 cups of coffee. She also knows that when she produces 8 cups of coffee, her total variable cost is $18. So profit is equal to total revenue minus total variable cost, minus the total fixed cost. So total revenue is $2 times 8, or $16, minus our total variable cost of $18, that's negative $2, minus our total fixed cost of $10. That means our profit is negative. It's a negative $12. Because total revenue is less than total variable cost, every cup of coffee she produces does not earn enough revenue to cover the variable costs of producing it. And she's going to lose the total fixed cost anyway. So producing these 8 cups only makes things worse for her. So in this case, she should shut down and close her business, because profit is 0 minus $10, or a negative $10. So then what is the shutdown rule for a firm in the short run? When should it stay open in the short run? When should it shut down in the short run? Well, there are 2 cases to consider. Okay? When the market price is below the minimum average variable cost, and when the market price is greater than or equal to the minimum average variable cost. The minimum average variable cost determines the shutdown price. When price is greater than minimum average variable cost, the firm should continue to produce in the short run. So the firm should not produce if total revenue is less than total variable cost. And so we have to look at how low must the price fall before shutting down becomes the right thing to do. So let's look at the shutdown decision again on a per unit basis. If price is less than average variable cost, then we should shut down. So assume the market demand falls even more. If the price is lowered from $5 to $4, the firm should stop producing. So the shutdown rule is a firm should continue to produce as long as the price is above the average variable cost. When the price falls below average variable cost, then the firm should minimize its losses by shutting down. Why? Because if the price is below average variable cost, the firm is losing more money by producing than they would have to pay to shut down. So here is a graph that shows the shutdown price. We have our U-shaped average total cost curve, our U-shaped average variable cost curve, and our Nike swoosh marginal cost curve. So we can see that where average variable cost is at its minimum is the shutdown point, where it crosses the marginal cost curve. So at any point below that, we would shut down because we would not be covering our costs. So if price is less than average variable cost, the firm should shut down. Producing nothing is cheaper than staying open. And you can see that by looking at the shaded areas in this graph here. fixed costs are equal to $10, total cost is $35, total revenue is $20, and in that case, the price being less than the average variable cost, they don't even cover part of their fixed costs, and they incur variable costs. So they shouldn't stay open. So here, we can see this in a graph of short-run cost curves. If the price falls below the minimum of the average variable cost curve, the firm should shut down, where price equals average variable cost is known as the shutdown price. So if you have to calculate the shutdown price, that's how you determine it, where price is equal to average variable cost. So at any price above point A, in this graph that we looked at here, any price that's above point A, the firm will produce where price equals marginal cost. But at any price that's below point A, the firm will supply nothing and shut down. So if price increases, output will increase along the marginal cost curve. If price decreases, but still lies above point A, output will decrease along the marginal cost curve. In other words, above point A, the marginal cost curve serves as the supply curve for the perfectly competitive firm. Below point A, it supplies nothing. So the supply curve for a perfectly competitive firm is derived in that way. Going from point A, where it will begin to supply in the market, and then going along the marginal cost curve above that point is the quantity it will supply. So the marginal cost curve above point A is the supply curve for the individually perfectly competitive firm. So there are three characteristics of the profit maximizing rule. The rule applies to all markets. Here we're talking only about perfect competition, but that rule is still true when we look at monopoly, oligopoly, and monopolistic competition. So it will apply in all four market structures. The rule applies only if price is above average variable cost. If the price is below average variable cost, then the firm will shut down in the short run and produce nothing. And thirdly, the rule can be restated that price equals marginal cost for perfectly competitive firms because marginal revenue is equal to the price for a perfectly competitive firm. Here is the Shutdown Rule video that you can stop and view on the ACDC Econ website with Mr. Clifford. This is an activity on the Shutdown Rule that we will do in class. Here are some practice questions. So I'm going to click through each one of these, and if you want to do it, you should pause the video and do it for practice. And then when you're done with each question, start the video up again and go on to the next question. Here's question number 2. Question number 3. Question number 4. Here's another video by Mr. Clifford for you to watch on the ACDC Econ website called Maximizing Profit Practice. Here is a question that was taken from the AP exam a few years ago. So there are 2 questions here with the correct answers circled. But you might want to pause the video and look at this question, see if you can answer it on your own and why those answers make sense. Because this is an example of a multiple choice question that you might face on the AP exam. This question appeared on a past exam. Here's the FRQ from the year 2007 Form B test from the AP exam. So here's an example of what a free response question on this topic might look like. This is the rubric for that question. So this shows you how you would earn your points for that question. So you might want to practice it and see if you could earn each of these points. Here's a graph that once again shows a profit maximizing firm. If you assume the firm can sell each unit at a price of $30, how many units should the firm produce to maximize profit? What is the total revenue at that quantity? How much is the profit? Notice that at 6 units, the firm is still making profit, but it's just not maximizing its profit. Notice here that at 6 units, the firm is still making profit, but as we said before, not maximizing it. Where is profit maximized? At 5 units. And that is where marginal revenue is still greater than marginal cost. At the 6th unit, marginal cost is now greater than marginal revenue. So we would produce 5 units to maximize our profit. Here is the free response question number 2 that appeared on the 2006 AP exam. You may wish to pause the video and see if you can practice this question and work it out correctly. Here is the rubric for that question. So if you worked it out and you practiced it, you can look at how you would earn your points for that question. Now let's talk about the individual firm's short-run supply curve in a perfectly competitive market. Remember, we said that a firm will only produce if the price is above the minimum of average variable cost. And in this graph, that is point A. And so that also represents the firm's shutdown price, because if the market price is any price below that, the firm will shut down and not produce at all. At any price above $10, the firm will produce, even if it's incurring short-run economic losses. And so point A is that point right here. So the yellow portion of the marginal cost curve is not part of the firm's short-run supply curve, because at any point below $10, it will not produce. But at any price above point A, the firm will produce a quantity along its marginal cost curve, point B, point C, point E. And if it will produce that quantity, that's what it will supply. So the firm's individual short-run supply curve is its marginal cost curve above the point that represents the shutdown price. And so in this case, the supply curve would be the marginal cost curve from point A upward. Below that point, there would be no supply. So here you can see as price increases, the quantity supplied increases. So here, the shutdown price would be the minimum of average variable cost, which would be a quantity of 5. So the shutdown price in this case would be $20. But the firm would produce, even if it's incurring losses, at any price above $20. It will shut down if the price is any price below $20. And the individual supply curve will be the marginal cost curve at any point above a quantity of 5 and price of $20 upward. And the quantity supplied will be represented by those points on the marginal cost curve. So the short-run individual supply curve we've seen shows how an individual firm's profit maximizing level of output depends on the market price because we take fixed cost as a given. We have to pay it whether we are producing or whether we don't produce. Now, the firm cannot change fixed costs in the short run. However, if the market price is consistently below the break-even price for a significant amount of time, eventually the firm will decide to shut down and exit the industry. Exit is different from shutting down in the short run. Exit means that all fixed inputs have been sold off in the long run, and the firm no longer exists. Shutting down in the short run means the firm still exists, but it's not operating. So on the other hand, if the price was consistently above the break-even price for a while, eventually new firms would want to enter the market. In the long run, new firms would be able to acquire the necessary capital inputs and join the existing firms. Remember that under assumptions of perfect competition, because there is easy entry and easy exit, there is nothing to prevent the long-run entry or exit of firms. So remember, in the short run, in a perfectly competitive market, the supply curve is equal to the firm's marginal cost curve at any point above the minimum of average variable cost. Here you see if variable costs increase, for example, if there's a per unit tax on a good, then the marginal cost curve is going to shift to the left. And that will become the firm's new supply curve. It will also cause average variable cost to increase because it's a per unit tax and you pay it on each unit you produce. Therefore, that tax goes up the more you produce. So it creates a new average variable cost curve and it shifts the marginal cost curve to the left. And so it creates a new individual supply curve for the firm. So when marginal cost increases, supply decreases. We've seen that before. But what if variable costs decrease? What if they get a subsidy from the government? Well, that will shift the supply curve to the right. And that will also decrease the firm's average variable cost. So you end up with a new average variable cost below the original one. You end up with a new marginal cost curve to the right of the individual one. And when marginal cost decreases, supply increases. And so the firm will have a new supply curve generated that looks like this one. But what happens to quantity if fixed costs increase? Well, fixed costs don't change anything. So quantity stays the same because marginal cost divided by the supply doesn't change. Now, a per unit tax or subsidy affects the variable costs. So marginal cost, average variable cost, and average total cost will shift. And that will affect the quantity produced. That's if it's a per unit tax, because if it's a per unit tax, it affects variable costs. The more you produce, the more tax you pay. The less you produce, the less tax you pay. So that's why it affects variable costs and marginal cost and average variable cost, and therefore average total cost will shift, and that will affect the quantity produced. But if it's a lump sum tax or a lump sum subsidy, it only affects fixed costs. It's not dependent on how much we produce. It's a tax you pay in one amount, and it's not dependent on what you produce. So only average fixed cost and average total cost will shift if there's a lump sum tax. Marginal cost will stay the same, and therefore this will not affect the quantity produced. So a per unit tax and a lump sum tax affect the quantity produced in different ways. One will affect the quantity produced, the other will not. Here's a multiple choice question from the 2008 audit exam. You can see if you can answer this. Here is an activity that we'll work on in class, a summary of profit and production for the perfectly competitive firm in the short run. And here is a summary of everything that we've talked about. I won't read this chart to you, but I would recommend that you pause the video now and review the chart on your own, because these are important concepts that you have to memorize and know about an individual firm's short-run production decision in a perfectly competitive market. Here is an example of what we've been talking about now. It tells you that in 2005, Congress passed the Energy Policy Act, that by the year 2012, there were supposed to be 7.5 billion gallons of alternative oil, mostly corn-based ethanol, that would be added to our fuel supply. So one farmer, because of this, increased his corn acreage by 40% after demand for corn increased. But that drove corn prices up. So even though the price of corn increased, so did the raw materials needed to grow the corn. So farmers will increase their corn acreage until the marginal cost of producing corn is approximately equal to the market price of corn, which shouldn't come as a surprise because corn production satisfies all the requirements of a perfectly competitive industry. Here is a video from Mr. Clifford that you can see on the ACDC Econ website called No Profit, No Product. And this is a summary of everything we've looked at on Module 59 and graphing perfect competition. And this concludes Module 59, Graphing Perfect Competition.